This is my lesson reflection for the final activity and discussion for this course. I don't have a class available to me right now, seeing it's summertime, so I kind of found the next best thing. I coerced my daughter, age 16, into helping me out. She's a rising high school junior. She has no experience with computer science. She hasn't taken any computer science classes in school yet. She's thinking about it maybe for her junior or senior year, but has not done anything yet. I also got my wife, who is a little older than 16, but she's a K through 5 media specialist and has also taken on a role in her school in the district she teaches in as a computer science teacher for these K to 5 students at least one marking period of the year. So she has a little bit of experience with computational thinking and computer science through the use of code.org. In this lesson, students needed to create a flag using Scratch and the pen module. Now, neither of my participants had ever used Scratch, so I had to give them a little background and show them how to use Scratch and how to use the pen module. But once they got the hang of it a little bit, it really wasn't too difficult. We use a website called flags.net to pick out a flag for that to do. My students, I've used this activity in class several times over the last decade, and students always seem to like it. They choose a flag. Actually, they choose two flags that they want to create. One can be somewhat easier, one should be a little bit more difficult. So that difficulty level is what kind of differentiates for different levels of students. And I work with students to help them pick something that I think is commensurate with their ability level. The flag has to have certain criteria that it meets, such as at least two different shapes and two different colors that are in the flag. Okay? Some things I emphasize when students start creating their flag. One, they should break their flag into its component parts, into rectangles, circles, whatever it is. That's an illustration of decomposition. And I also encourage them to write new blocks for components that they're going to use more than once, or blocks for components where they can define it separately. And that's a use of abstraction. Here's the code that my participants came up with. You can see the code all the way to the left is the main program running that starts when the flag is clicked. And you can see that there are a couple of times where it calls other code that was created. One for a rectangle with parameters for width and height, and another one for a circle with a given radius. Let's go ahead and demonstrate this program running, making the black rectangle, the red rectangle, and then it's iterating through the circle to create all the little sectors that actually create a filled-in circle. This is creating the Aboriginal flag. Over the years, students really enjoy this activity, and I've used it with a number of different programming languages, from Racket to Python, anything that has a way to draw things. So it seemed to fit quite well with Scratch and the pen module. It gave me a chance to explore one of the different modules that's not automatically installed with Scratch. You have to go out and add that module. As the students are creating their drawings, if they come across shapes that are a little bit more difficult, such as stars or crescents, things like that, they're encouraged to share how they constructed those with other students. So if another group is struggling with a shape that some other group has already mastered, share the code with one another. Okay? I really encourage a collaborative nature in the classroom. Grading for the activity is done on a scale similar to scoring a diving competition, where if you attempt a flag that is quite difficult, your final drawing doesn't have to be quite as perfect because you've attempted something really difficult. Whereas if you attempt something very easy, your picture should be a little bit more accurate to what the real flag is. That way everybody can pick something that's commensurate with their ability level, and everyone can be set up to succeed. Some of the students are very independent with the activity while others need more assistance. And some students seem to finish a little quicker, as with a lot of activities. So I try to get some of those students that finish earlier to help out some of the students that are struggling. One of the ways that we share our flags at the end of this lesson is through a gallery walk, where students can not only see the flags that were created, but they can also see the code that goes along with it. The kids really like seeing different ways of doing similar things. There's more than one way to create a rectangle. There's more than one way to create a circle or a crescent or things like that. So the students really kind of enjoy that. One of the promising practices I had talked about in a previous assignment was about sharing some of the computational thinking and computer science activities with the rest of the school. And this is one of the activities where students create something visual, so it's easy to share with the rest of the school. I will print out copies of the flags and the code and post them in the display case next to the library, and which also happens to be right across from the computer lab where I teach. Students like seeing their work in there that's displayed for everybody else, and oftentimes I'll see students walking by with their friends and pointing out, oh, that was the flag I created, and explain to them, hey, here's how I did that with these different lines of computer science code, some different lines of code. So that sometimes even is enough to get students interested. I also use some of them to display with other artifacts when we showcase our curriculum to the public in different venues. Okay. This is definitely an activity I've used in the past with different languages, and I will continue to use. Students really seem to enjoy it, and they have fun with it, and they often talk about it well after the activity in subsequent years. Thank you.